Welcome, everyone, to the Energy Advisors Podcast. I'm your host, Rex, that energy guy. Glad to have you, no matter where you're listening around the globe or watching on the video platforms. Excited to have this conversation today. This is one I've had on the radar for a little bit of time, and it's pretty exciting technology that's being brought a little more into the widespread adoption in the residential marketplace. So I think you'll be impressed with this technology and the folks that are bringing it to us. But before we get started today, we always want to thank our sponsors in the program, because without them, we can't do it. And we're very thankful for their partnership. Our good friends at Smart Energy Centers, which are bringing renewables across the country to many retail locations. Excited what they're due. SmartEnergyCenters.com. Our friends over at Tax Hive. Taxes play a huge role these days in the adoption and deployment of many renewable technologies. Our good friends over at Tax Hive want the truth without getting mixed up. Don't do it yourself. Do it with our friends at Tax Hive. And then again, of course, our friends over at Go Green Community Initiative. These folks are doing great things to help communities drive adoption of renewables across the country. GoGreenCommunityInitiative.org. Okay, without further ado, I'm excited about this one today because I'm a technologist and I'm a geek at heart. And so when I find something new and cool, man, I just can't wait to get my arms around that and tell people about it. And we've met and I've reviewed their technology, and it's some pretty cool stuff. So I'd like to introduce our guests with us today, Brooks Norman and Justin Weatherspoon of Factor Up. And gentlemen, glad to have you with us on the program.
We're excited to be here, buddy.
Thank you, sir.
You bet. Well, it's not always just about the toys and the cool technology. We want to know the story behind all this. And so I'd like to get into this, what Factor Up has been doing, the story behind it, and how you guys came together in business. So I don't know who wants to lead out on that, but take it away, gentlemen, and let's hear the story.
I mean, I can take a little bit of a lead here. My background for 15 years was in the wealth management space, and my family had a brokerage, and so through that, spent a lot of time networking, meeting a lot of people, and we stumbled across this technology. Whenever we took a look at it, we saw the potential for what this could do, and so reached out to everybody that I knew in my network that had experience in the energy industry, and said, "Hey, this really needs to be something you guys take a look at." And once everyone put their eyes on it for the first time, they said, "Man, I think this could be something that not just builds a great business, but also makes a really big impact as far as the structure of the grid and the strain on the grid, all of those things. So it can make a really big impact for America, not just building the business." And so then we all decided we were going to throw our hats in the ring and come together and make this thing happen.
Okay. Now, Justin, you're the man out in the field. So tell us a little bit more about how this came together.
Yes, sir. I was approached by Brooks about a year and a half ago in regards to the technology and how it worked, and as a 25-year licensed electrician and whatnot, it was kind of eye-opening to me as far as the different impacts that we're looking at as far as the overall energy demand and consumption is concerned, and how this technology, while it's 20 or 30 years old, and quite honestly, it's longer than that, more like 50. But as it is getting to the point of being able to be rolled out in a much larger scale, it was very eye-opening to me about how it would affect not only my family, my farm, but also the oil and gas industry, the commercial industry across the board, as far as energy consumption and reducing that. as well as, like we talk about, increasing the lifespan on a lot of the loads. So we continued to grow and get closer together and realize all the different areas in which we could push it. They just never stopped coming. It seems like we've got specialists in multiple areas that are kind of honed in on their own line, if you will, and going in that direction.
So you mentioned, Justin, that you've been a licensed electrician in the field. Um, Tell us a little bit more about where you guys, started using this technology, and then maybe let's quick before help our listeners. What is it that we're talking about here, and then where did you see the initial implementations?
Sure. As it pertains to the NEC and being able to have your license and everything, that's kind of your end all be all, but it's also a minimum rule, right? And so what our system does is it corrects a lot of the line losses that you see that is in any AC style installation. That allows for a reduced consumption across the board. So some people look at it as power factor, some people look at it as other opportunities to be able to reduce the inductive load as far as surges and things like that are concerned. It is something that is, as an apprentice, and quite honestly, all the way up until the time that I had been approached by Brooks, I never really looked at it. It was always, you go by the NEC, and if you can do better than the NEC, then so be it. The authority having jurisdiction always outrules the NEC, if you will. And when you start looking at it and being able to show it and being able to demo it face to face, I mean, you've seen the demo, of course, and when it comes to that, it definitely sets itself apart from what I've seen in the past as far as anything electrical savings wise.
Okay, so let's talk
So
about this a little bit. Go ahead, Brooks.
I was just going to say, the birthplace of this technology is really with the power companies and the power suppliers. What we do has been utilized on an industrial scale for years, but it's never been taken to the general public. And so with what has happened and kind of where things are shifting, where now electricity costs are rising, the costs of producing some of the different components that are within our system are dropping. Now we've hit this beautiful sweet spot where now it's a huge financial advantage to a residential homeowner to be able to implement this piece of technology and get an easy 10% off of their electricity bill. So I mean, in certain cases, it's higher than that, but an easy 10% right off of their electricity bill. So,
Okay. So, a couple things to help our listeners because not everybody comes from this field. Justin, what's the NEC?
National Electric Code.
Okay, so that's when you're talking about
It's the code
NEC,
book.
and it's the code book, it's the rule book.
Correct.
And it's not like Pirates of the Caribbean where the code is just a suggestion. This is actual, real code that people have to adhere to, and that's how you get your licenses, right?
Yes, sir.
Okay, fantastic. So I want to talk about this a little bit. So we talked about this off air another time, is there's a difference between what you're billed for and then what you actually consume. Okay. What did you see in the oil fields and industrial applications of this? And then what does that look like in a residential situation?
so in the in the commercial and oil and gas industries, the two biggest drivers on any commercial electric bill is one is the peak demand. Okay, so what's the most amount of electricity that a facility or an installation is drawing over any given month. And then the second one is just the usage. How much electricity goes through the meter that you're now being charged for. And what we found is that there are some pretty large inefficiencies that exist within most electrical systems, specifically within most inductive loads. And so any spinning motor, right? So you're talking about compressors, pumps, anything like that. And so what this does is this captures and recycles the electricity that you have been billed for that otherwise would have been wasted. And so, in oil and gas, we've seen we regularly see a 25 to 35% reduction. We've seen numbers that are even crazier than that. I think the craziest one we ever saw was a close to a 60% reduction in usage, and that's just because of some of the unique things that oil and gas deal with, and maybe other places don't. Um, and so, and then you move to commercial applications. You got big HVAC units. A lot of times you have compressors, stuff like that. And so there it's really easy to get that 15 to 25% savings. And then you go down to the residential side. And, on the residential side, there may not be the massive inductive loads that there are on commercial applications or in oil and gas, but there are still inefficiencies that exist within a home where the client is paying for electricity that's now not being used. And
Okay.
a lot of times that electricity ends up getting donated back to the grid after they've already paid for it. And so when I go to a steakhouse, I typically, if I order a 10 ounce steak, I'd like to get all 10 ounces of that steak. And so I feel like most consumers feel the same way about their electricity. So
Yeah, I think so. So, Justin, well, the first time we met, you were telling us stories about inefficiencies on the pumps at the oil, the oil pumps and stuff. Can
Sure.
you share that a little bit? Because that helps people kind of get their head around what's going on.
Yeah, sure. So the discussion I believe we were having was around uh, sporadic loads, if you will, when a pump goes under load or it comes out of load, for like a pump jack, if you will. As it goes up, it goes under load. As it comes down, it drops. So what ends up happening on our side in the oil side of the world is, there's a balance there. So if you've got your pump jack tuned correctly, if you will, with the production and everything, it stays at somewhat of a level amperage, if you will, or consumption. If not, if there's anything sporadically that happens, a lot of times we're going from, I've seen anywhere from instances of 95 amps to 25 amps, and even lower at the very bottom. It'll drop off completely to where there's no load on that motor. And then as it comes back around, it jumps back up to 95 again. So what our system does is it takes that inrush. It's the same thing. It's the same thing as starting and stopping a motor just at any point in time, whether it's a compressor, whether it's a refrigerator, what have you. On the residential side, it's just a much bigger load, of course. But as it drops off and starts back up, that inrush kicks back in order to keep it spinning. And what our system does is it levels that out to a point in which I think that same facility on a demo we did for them was roughly around 35 across the board, 35 to 40, to where it just balanced the load across it. Basically, and in doing so, allowed for less kilowatt hours to be paid for, basically, or spent on.
So essentially, what's happening is that pump in motor is trying to work, and the fluctuations of the power would mean it's always working and drawing more electricity because it's not working effectively. Correct?
I Yes, to an extent. I mean, for the most part, it's what happens to any electromagnetic field or anything like that when it comes to even transformers, for instance. They're not 100% effective, or excuse me, 100% efficient. My apologies. And in doing so, our system just corrects the majority of that inefficiency.
Okay. So, putting it in the everyday common person who isn't reading the NEC, um, is it really acting as just like a surge protector, or is there more to it?
So there is more to it. It's capacitor based with line chokes and everything else that goes into the box, if you will, that allows for the inrushes to be consumed by the capacitance and not coming through the meter, if you will, or being charged for it. And then also for the idea of anytime that we're running, where the line loss that is created from, say, for instance, your air conditioning unit to be on the opposite side of the house from your meter, for it to correct that line loss that happens day in and day out, the waste.
So, okay. So effectively, going down to a residential application, it's not fair to say it's leakage, but when explain line loss for the average person.
So NEC as a minimum rule, the farther away from the source you are, the bigger the wire needs to be in order to reduce the amount of line loss, if you will, as far as voltage drop. Certain instances it's 3%, certain instances it's 5. As an apprentice and as an electrician, a lot of the times the electrical engineer will go ahead and tell you what size wire you need to run. However, at the same time, not always is that followed, because during construction you might have a unit that moved 300 feet away or got 200 feet closer. And so when it comes to that, it's basically the inefficiency that happens because the AC runs in waves versus running like a DC current directly down a line. And the amount of impedance that happens is what we're correcting.
Okay, fantastic. So how are these installed on a residential application? Yes, I do have people who are commercial listeners here, but let's just take, let's Rex's house. How does this look like a configuration?
So on a, and I can, even though my background was in electricity, I can actually take this one because it's a pretty simple install, which is
Okay, right.
a nice thing. So the biggest bang for the buck for the client is to install one of these at their main breaker panel. So really what that installation looks like is you mount the box close to the panel. You're going to run some wires in the panel, and then there's a 2-pole breaker that you clip right into that breaker panel. And what that's going to do is everything that Justin's talked about so far. It's going to provide some whole home surge protection up to 20,000 joules. And then the other big thing when you talk about the residential market that we haven't really talked about too much yet is harmonic distortion. So in a typical home, you've got a bunch of electronics that are running. And so all of those electronics, there's converters, in your charger to your laptop, to your cell phone, your television, all those things. There's converters that convert that AC current, which is what the utility company delivers, to DC. Well, in that conversion process, it creates some harmonic distortion. It creates spikes in the current of the electricity. And so that ends up tricking the meter to registering higher usage than what it actually takes to power those devices. And so the other thing that the Factor Pro is able to do is it's able to smooth out and mitigate some of those harmonic spikes, which again just results in a lower bill for the client.
Okay.
And
Now, I also understand that you can further optimize your systems if you were to put one of them in front of your heavy consumption appliances, say AC units, a pool pump, hot tub heater, those types of things. Is that correct?
Absolutely. So, in typical home, the largest motors, the biggest draw typically that a client is going to have is going to be HVAC and pool pumps. And so when we apply a unit, directly as close to that load, as close to that motor as we can, we're going to further optimize their savings. And it's going to optimize the flow of electricity to that equipment, which causes the motors to run cooler, which also extends the life of the client's equipment as well.
Okay. So let me get this straight. And one of the things that's very popular, if you look at all the renewable technologies out there, so we're talking solar or micro wind turbines or heat pumps or, heat pump water heaters and all these things to reduce and create more efficient homes. Heat pumps have become very unpopular. Okay. Heat pumps are actually the only one of those things that I just listed that have double-digit adoption rates. So Why across the country, solar roughly across the country is like 4 or 5%. Depends on whose reports you listen to. Heat pumps around 15 to 18% adoption rates. But what does a heat pump run on? Electricity.
Right.
So when you install a heat pump, and whether your heat pump is just used for heating and cooling or also water heating, it's a big electricity draw. So how would the impact be if you put one of these right next to your heat pump?
Justin, you want to take that one?
Yeah, it's the same thing as an HVAC unit, if you will. A lot of times, so our system works on inductive loads mostly or mainly. It does not do anything with like a resistive load or anything on like a water heater or something like that where it's got a coil that's in it. It really
Yeah,
doesn't help out on that, but it will help out as far as the heat pump's concerned. Because my understanding of the HVAC world and heat pumps is basically there's just a valve that makes the flow go backwards, if you will,
right.
the HVAC. And so you're still using the compressor just like you were if you were using it on the on the air conditioning side. It works the
Okay.
same way.
Works the same way. So it'd be advantageous to put one of these in with your heat pump, right?
100%. Yes. And like you brought up the solar side, the wind side. The solar side, one of the drawbacks to solar is, and I know we've discussed it, and I can't remember exactly what the Colorado side is where you're at, but one of the drawbacks to it is being able to size the solar panels to the load, right? Well, the
Right.
problem is you can size it to the load, but you can't size it to the inrush because of rules and
Right.
regulations. And so in doing so, our system would assist that solar, the solar installation and keeping the inrush from getting quote unquote from the grid. It would keep it in-house to where you're not getting charged for that as well.
Okay, good. Well, that's good to know because a lot of the people we talk energy efficiency and all these technologies, but I'm always careful to say, think of the use case because the use case is always important. There's no blanket answers to anything when it comes to electricity because at the end of the day, what are we trying to do? Get cheaper electricity. I mean,
That's it.
what we're doing and then use it more efficiently. So the sort of progression, if I understand, maybe we could talk about this for a few minutes. This technology was really heavy in industrial and say oil and gas, but then it's found its way into some of the larger restaurant chains. And so those talk about the progression, how this has cascaded, because it's a lot like many technologies. It's expensive and used in big industrial applications, and it slowly migrates down. So could you talk about that for a couple minutes?
I mean, the biggest thing there is you look at the way it's migrated down, and it really has to do with when did it become financially feasible for this to be a something that is going to give the client the return on investment that they're looking for. So when we're talking about oil and gas and heavy industrial, you're talking about facilities that are using hundreds of thousands of kilowatt hours that are, I mean, we've gone and done some work on facilities that takes $5 million a year just to keep the facility, just keep electricity to the facility. So yeah, and something that can come in there and knock 15-20% off of their electricity bill, man, that makes a real big dent real fast. And then as electricity costs have risen, okay, then all of a sudden some of the smaller commercial change, restaurants and stuff like that. Now all of a sudden they get real interested because they're like, hey, our electricity bill and our electricity costs are going up. There are more things in a lot of those restaurants now that require electricity. And so now, hey, we're looking for a solution. And then, the last group that now we've hit that sweet spot where, man, now it makes a whole lot of sense for them to go out and implement technology like this would be the residential home user. I mean, you look back even 10, 15 years ago, and what were people paying for electricity then compared to what they're paying now, right? People went from $75 electricity bills to $350 electricity bills. So now it's, hey, let's come up with a solution. Let's figure something out so we can save some money.
Yeah, that generally is. I always tell people there's one thing to follow, money. And that, whether you, it has to do one of two things. You either have to have a technology that saves people money or makes people money. And that kind of was where it sorts out. So this is now being, again, it's under all these non-disclosures because we have to be careful, but your technology has been adopted by several restaurant chains and in large numbers, correct?
Yes. Technology's
Okay.
been using, yeah, quite a few different chains um and been implemented over a large sample size of those chains as well.
Okay, fantastic. So for the residential market, what do you think? And I know, and if the ROI, and let's address this for a moment because it's always about use case. Okay. If I live in Southern California and I'm paying 65 or 70 cents a kilowatt for electricity, that ROI is going to uh, be pretty quick, right? Those short.
Yes.
But if I live in Idaho or Iowa or some places where I'm 9, 10 cent a kilowatt, it's going to be a little bit longer. And your guys' analysis, what has made it, what do you think a good average would be for an ROI?
Uh, I mean, a good expectation is anywhere from 24 to at the top 28 months. If
Okay.
you're looking across the entire United States, I mean,
Yes,
obviously,
right.
like you said, there are hotbed states where that number gets cut down pretty dramatically. But if you average it out across the U.S. and the cost of what clients are paying, that's a pretty safe estimate right there.
Okay.
Which if you're looking at it, and that's again looking at it from one perspective, which is just what's the pure savings on my electricity. That's not necessarily looking at it as, hey, look, I have whole home surge protection that pays for itself,
Mhm.
right? That's a pretty cool thing. um,
Right.
and I'm also doing a better job of maintaining and prolonging the life of the equipment that's on my house. Those are pretty big bills whenever a client gets hit with replacing an HVAC unit, or they got to go replace compressors on different things that they have at their house. And so now we're helping extend the life of that as well. So
That's a really good point. Every appliance that you have, and I'm going to use the word appliance to be very broad brush. So from a toaster to your AC unit, right? Okay, so everything has a life expectancy. I used to have a home improvement radio show way back ago. It's been about 20 years, and people would call in and say, "Oh my gosh, I'm having this terrible karma. My dishwasher just went out. My oven went kaput. So did my refrigerator. What's going on? Do I just have bad karma?" And I would think to myself, I would not say this over the radio. I would say, "You nincompoop. It's about life cycles on your appliances. They're made." So I would just ask him, "Well, how old's your house?" "Well, it's 15 years old." "Well, then you can expect these things to wear out." And so it's a really good point, and you probably don't have data yet because these aren't as widespread as they will be soon. Is the fact that it will help with the life expectancy of those appliances.
Mhm.
we do have a little bit of data, and the data that we have is for every 10 degrees that you lower the operating temperature of a motor, of an inductive load, a spinning motor, you're going to
Right.
extend out, you're going to double its life expectancy. Okay.
Wow.
So I mean, when we're talking about some of these larger industrial applications, there we see 15, sometimes 20 degree drop in temperature. When you're talking about the smaller appliances in the house, we'll see a 5 degree. I've heard of 10 degree drops in temperature, but the impact is not going to be quite as large just because it's a smaller application.
Right. You made another good point. It's more than a surge protector. So I don't want anybody to get out there thinking, "Oh, I'm just talking about a surge protector." It's actually a surge protector plus more that actually pays for itself. That there are not a whole lot of appliances that pay for themselves. You're starting to see more of them become more efficient. So that's really interesting. So from the lens of a homeowner, okay, and all of us generally are, I can see a reduction in cost of my electricity, and I can see a lengthening in life expectancy of my appliances. And depending if I put multiple of these on, say in front of a large device like a heat pump or a AC or a pool pump, I'm actually going to gain even more efficiencies. So is that a fair way to say it for the average person like me who isn't reading the NEC code?
Yes.
Absolutely. Yeah.
Yep.
Okay. So what do you see on the horizon? What's next with this technology? What are you guys working on? There's a really cool demo that exists at energytransitiontools.com. You can go there and take a look at the page, energytransitiontools.com, or you can take a look. There's a demo video of that. What's on the horizon? What are you guys working on in the future without disclosing all your double dog dare secret technology?
Yeah, I mean, some of the things that we're working on is obviously the industry is continuing to evolve, right? There are more efficient machines that are coming out constantly that have different components that again are trying just to do what we're doing as well. They're just trying to save the homeowner, trying to save the end user some money. And so we work diligently to make sure that we are staying ahead of that curve so that as all of the new technologies are rolled out, we want to know what technologies are being rolled out, and then are there changes that need to be made to our technology to make sure that interfaces with the newer technology and still provides that benefit to the homeowner.
Okay. Anything else you want to add to that, Justin?
Yeah, I mean, there's definitely like we talk about, as soon as, I came on board, that it was kind of eye-opening as far as what we could get into and how much effect we could have on community involvement and whatnot. Everything from schools and government facilities all the way down to the end user in the residential home. Oil and gas is a huge focus. There's several other upcoming industries that is being supported by whether it's government funding or outside of that for the time being, to kind of help prop them up, that we've been approached about, and we are actively working in that direction.
Okay. Now, you just brought up something that's always important, financial issues. These do, if I'm correct, and you guys can tell me not, these do qualify for tax credits with the ITC because it's part of the energy home improvements for the resident. Is that correct?
That is correct. So if one of these were to be installed, then the homeowner would be able to apply for those
Tax
tax
credits.
credits at the end of the year.
Yeah. There aren't many surge protectors that are going to basically get a ITC, will they? No.
No.
No, that's the way it works. So no, it's really cool and interesting technology. I love it. So when I talk to homeowners, in fact, I was talking to one early this morning, and she wants to go green, and she's a doctor, and she's really enthusiastic about it. But I always tell her there's three pillars to energy. There's things that will help you conserve. There's things that will help you better efficiently manage. And then there's technologies where you can generate. And this really kind of covers two of those, as far as conservation and a better efficiency. Is that a fair thing to say?
Absolutely. Yeah.
Okay. Well, I'm excited about the technology. Looking forward to this getting widespread adoption. The affordability is amazing. So we generally try to stay away from giving price points out there because different things in different marketplaces. But I can tell you this: if you look at it, it's amazing. You can go get information, as I mentioned, at energytransitiontools.com. All right. Well, anything else I'm forgetting today, and then I can get on to my final fun questions that I throw at everybody.
I don't know. I don't have anything. What about you, Spoon?
No, I'm good, bud.
Okay.
Like I said, if there's anything that pops up between now and later on, let me know.
Okay. All right. So I always ask this of all my guests, and one of you gets an advantage because you get to go first, the other. There's this concept of a bucket list, things we want to do before our time is through here on this world. Some people, it's a crazy thing. I'm going to go climb Mount Everest or jump out of airplanes or ride a symphony or whatever. But there's an opposite of everything in the universe, right? So yin versus yang. So if there's a bucket list, well, then there's a effort list, things I don't ever want to do, right? But this is a family show, so we don't explain that, but it's an effort list. I have things I have no interest on. Now, Brooks, I'm going to pick on you first, okay? So what might be something that's on your effort list, something you have no interest of ever doing?
The one that it's a little surprising to some people because it's pretty common, but I don't ever want to touch it, is I never, ever, ever, ever want to willingly jump out of a plane high above ground.
Okay. That's a great qualifier. High above ground. If it's parked, hey, no problem, right?
Yeah.
No
if it's on tarmac and there's some padding beneath me, I'll probably do that. But I just, I'm 6'9". I'm high enough as it is. I don't need to get any higher, and I definitely don't need to be jumping out of anything that's high, that's that high in the air. So
boy, 6'9". You have a view most of us don't have, Brooks.
yeah. I see everyone's bald spots before they even know that they have them. So
well, I was going to say you got a forehead that would compete with Peyton Manning, but you're even taller than that guy. Is it? All right.
That's good. That's good.
All right, Justin, how about you? What's one of those things?
Yeah, to be honest with you, I mean, Brooks kind of stole mine because that is definitely not. I've had family members that jumped out of airplanes in Las Vegas and all that stuff, and doing it at night and seeing all that. Just nothing about that really gets my chilies going, or whatever you want to call it. But quite honestly, on my side, just to me, it would be like, I don't know, being a CEO of a company or something like that. I don't have the desire for that. I have the desire to truly give back to the community. We have the desire to be able to truly put our footprint on everything that we've got going on, and have people say thank you across the board, because that's all we're ready for is to tell everybody else thank you.
Oh, that's good. Well, one of mine, because in fairness, you have to share. I have a lot. So, but for me, if you're familiar with Raiders of the Lost Ark, when Harrison Ford dumped into the room in Egypt and all the snakes, you can leave me out of that 100%. 100%. My grandma had bull snakes and things in her garden when I was a kid, and I'd run across that, and that just scared me. That scarred me for life. And headless chickens bopping around when she would butcher chickens. So, something like that. Well, listen, gentlemen, it's been fun to have you on the show today. You guys are doing some amazing technologies. Again, if people want to take a look at this, it's available at energytransitiontools.com. We thank you for coming on, and we're going to look to have you return when you have more updates and things happening in the industry. So thank you for coming on. Well, folks,
appreciate you having us.
Thank you for coming. Well, folks, that wraps up our episode today. We want to thank everyone for tuning in wherever you are around the globe. We want to thank you for our sponsors who are providing the show for us. And as I say and do every time, thanks, and make it a great day.